Welcome all, my name is Ermin and I will be your instructor throughout this course. I'm also its creator. So, in this introductory video, I usually like to go over a few things in regard to the course, like who is it meant for, what are the prerequisites for it, what sort of level of knowledge is expected from you, what other benefits do you have, why should you learn C++, etc. So, first things first is why should you learn C++? Why is that important at all? First of all, C++ is a low programming language. It has a very messed up syntax in a sense that it is not user-friendly, so to say. But it is very powerful. It is able to do things a lot faster you're able to do things a lot faster with C++ than you are able to do with other programming languages. It is very low level. It is down to the core. It has direct hardware access. For example, if you compare it to Java or, maybe to Python or C# or something like that, all those languages are considerably slower than C++, although they are a lot easier to learn, I would say anyway. However, C++ does give you an enormous amount of freedom, and therefore you can make a lot of mistakes while coding, but that's the beauty of it, that you do have the ability to do pretty much whatever it is that you want to do, even though it perhaps sometimes makes no sense. Anyway, games today for PCs, they are made in C++. So most of the major games out there are made in C++. This is done because they're fast, they're optimized, and they can work. Some of the games which are written in Java or some similar programming language for the PCs, they will be considerably slower than the ones written in C++. Also, operating systems are written in these low-level programming languages as well. In addition to that, you have a number of desktop applications, and on top of all of that, I personally find C++ very interesting and very useful, especially since I'm in the pen testing world. The fact that you can do anything that you want with it, that there are pretty much no limitations, enables us to write pretty much all sorts of code that we would need. For example, in the other course where I have created instructions on how to create a keylogger, that was done in C++, and that is for advanced audience who are already familiar with C++, who already have a good amount of knowledge from before. But in order for you to be able to write something complex as that, you would need to learn these basics. So the keylogger, it could have been written in C#, it could have been written in Java, etc. But why did I opt to actually write it in C++? Well, first of all, minimum amount of dependencies, practically no dependencies of whatsoever. If you wrote it in Java, you would have to have a virtual layer underneath to actually run, and Java runtime environments, they're not installed on every single PC out there, so that is a problem. Also, if you had C#, you would again need a sublayer. That's another dependency, which is not something that you want to make such programs dependent on. It also there are a good number of frameworks there, but you don't really need them to actually be able to work in C++. And the keylogger, the way it was written, it was just pure code, no frameworks, no nothing, from scratch, write it and make it work. But that was for the advanced audience. This course is completely different. This course will show you the backgrounds of making a keylogger, so to say, because we will go over all the basic things, like from square one and onwards to more advanced things in C++. So you don't really need any previous knowledge of coding, programming, or C++ in order to take this course. It was designed so that anybody pretty much can take it, and they can go at it, they can learn from it. It does require some work on your end. I mean, it does require you to actually go through the videos, take a look at the code, try to create your own code, and perhaps, take a look on the net for some extra resources. There are a lot of them out there. So keep that in mind. Also, C++ developers have the highest salary, one of the highest salaries in the world. I think that I'm not sure, like assembly, I think pays more, but something like that. But C++ C++ programmers have one of the highest salaries in the world as opposed to the PHP programmers or anything like that, primarily due to the fact that it is extremely complex. I don't know, in recent years I think it's on par with Java in terms of salaries, but it ranks up pretty high, so keep that in mind. There are plenty of jobs for it, both in the freelancing market and pretty much companies also request it. So it is a very popular language. It's been around for a very long time, and the new refresh with the C++ 11 standards they're basically like godsend, because a lot of standardization has been done. Some new very useful libraries have been added, and you have some fantastic functions that are out there as well that we will go over. So we will go from square one and we will keep on moving towards the more advanced things, and it will get very complex in a relatively short amount of time through the course, and you will be able to learn a great deal. Now, in addition to all of this, you have the Q&A section. In the Q&A section of the course, you can post any questions that you might have. There will always be somebody there to provide you with answers. So if you encounter problems, if you can't compile, if your code doesn't work, etc., please go to the Q&A section and somebody will be there. I usually hire people to look at the Q&A section continuously and provide you, the students, with answers so that they would help you out, so that they would make the ride smoother and provide for a better experience overall. Another thing is that my YouTube channel is out there, and there'll be a link somewhere here. I usually create announcements there. I create updates in terms of vlogs, and I state, for example, okay, next month we're going to be doing this. This is the next course. This is what I was planning to do. You'll be able to stay up to date, etc. And also, please feel free to send me private messages in regard to requests. So you can request particular content to be added to the course. That is also one of the privileges and benefits that I leave for my students. So if I've skipped something in regard to C++, if I haven't explained something that well, or if I made a mistake somewhere, something like that, please feel free to send me a private message, or feel free to send me an email or on YouTube. It really doesn't matter. Contact me however you wish, and tell me, like, hey, I would like you to explain this part, and I would like you to explain this part. Hey, you didn't explain this. Could you add this to the course? Now, there are no guarantees that I will, of course, add these videos, but usually I do, as long as it is something reasonable. I go the extra mile and I make it. And it's going to get posted in the course. Why is this important? Well, I don't know, if you're a student, high school student, or a college student, or whatever, and if you're struggling with a particular subject in regard to C++, you can make a request, and perhaps I can make videos in regard to that subject to help you along the way. So that's very nice. You can also post suggestions for other courses if you like. You can post suggestions for content in general, what you would like me to provide you with. Also, the review system. Yeah, please leave the reviews. They are very important, of course. But if you leave a bad review, that is your right, and you are fully entitled to it. Please leave a comment down below, like state, I didn't like this, and this, and that is why I gave 1 star or something like that. Just explain why you gave a negative feedback so that I can act on it and perhaps change it or improve it or do something like that in order to provide for a better experience. Anyway, I do believe that would be it as far as the course in C++. Aside from all of that, you can see my working environment here. Not the cleanest or the neatest of working environments. They're just monitors, ton load of cables on the table, ton load of cables below the table, keyboards. I think I have 3 or 4 machines here working, plus God knows how many virtual machines, etc. It's really chaotic because I do all of my stuff here aside from Udemy as well, and sometimes I spend 3 days in this room, like not going out, anything. I bring the supplies in, and that's like my temple where I stay for 3 days when a project needs to be done. Anyway, I'm always accessible. I will always answer your questions. Doesn't matter who you are, where you're from, or whatever. If you send me a private message, I will do my very best to answer. Whether you're my student or not, doesn't matter. I will do my best to answer. I answer all the questions, and I read all of my emails and questions and inquiries and anything like that. So if I miss you by any chance, or if I don't reply to you, just send the same message again so that you get pushed to the top of the stack, because I receive like 100 inquiries per day, and I really do try to answer them all. But if I miss one, I am so sorry. Just send another one, just copy paste it and send it again. It's going to get pushed to the top, and I will do my very best to answer it. Anyway, I would like to bid you all farewell and wish you a ton of luck with this course.
Welcome all to this tutorial. Today I'm gonna go ahead and show you how you can set your development environment up. Now I personally am using a Linux operating system. Here I'll show you how you can actually install the IDE via the terminal, but I'm guessing that most people are using Windows. So also I will show you how to do it in Windows. Now keep in mind that the procedure for Windows and for Macs, it's pretty much the same. I mean, it's very, very, very similar. If you really need me to show you how to install code blocks on a Mac, just send me a PM or something like that, and I'll make an extra video. We just download a file and run it. That's basically it. But I'm gonna go ahead and show you how you can conduct an installation on Windows and how you can do it on Linux. So it's fairly simple. As I said, I will be using I'm not sure if I've actually mentioned it in the intro, but I will be using a Windows machine I will be using a Windows virtual machine for the demonstrations of this tutorial, but it really doesn't matter which operating system you are using. Once the development environment is set up, it will be the same across all platforms. It will look the same across all platforms, and you will use it in pretty much the same fashion across all platforms again. So the integrated development environment that I have chosen to use today is basically code blocks. Why code blocks? Well, for Linux, it doesn't really matter. For Linux, you can use pretty much whatever development environment you want, and they're all fairly easy to set up. But for Windows, sometimes you can have compiler problems, and you need to link it manually. It can get complicated. However, with code blocks, you get a compiler with the integrated development environment. So you basically just have a file which you download and run, and that's it. You can begin your programming session. It's fairly easy. There is nothing particularly difficult to do there. I mean, it's fairly easy, so you don't have to worry about it. That is the primary reason why I have chosen to use code blocks, due to the ease of setup. I generally tend to use Eclipse for C++ or for Java. I don't do a lot of work in Java anyway, but for Python, I tend to use Spider. Those are all the development environments which you can set up. Now, some of you might ask me, why don't you use Visual Studio, blah, blah, blah. But yeah, you have to Visual Studio is a pretty complex development environment, and I don't like the way things are compiled when you take Visual Studio. For example, in the keylogger course, while the keylogger was being made, if it was compiled, for example, in Visual Studio, it wouldn't behave the way we wanted it to behave. But for example, if we compiled it within code blocks with a compiler that came with code blocks, it would behave exactly the way we have intended it to behave. So I don't know, those are just some of my own personal preferences. To tell you the truth, and to be honest with you, you can use any development environment for this course that you want. Just set it up and make sure that it's running, that it's functional, and you won't have any problems with it as long as it comes with a compiler, or that you know how to link a compiler to the development environment. So let me just quickly show you how you can install it in Linux. Just open up a terminal, type in dnf, search code blocks, and there you go. So you indeed have code blocks right here. So you can type in dnf install code blocks, and this will basically just go ahead, run, and install code blocks without any problems or difficulties. It is in the default repositories, and I personally find that the installation is probably the easiest in Linux. You just type in one command and it's done. You don't need to go visit any sites. You don't need to go searching for it online. You just have your internet connection. You type in a single command. It gets pulled from the repositories, installed, and set up for you in to the fullest of extents. So let me just launch it to make sure that it's running, to make sure that everything is fine. Code blocks. Okay. Current default compiler, GNU GCC. Yep, that is what I want. As you can see, there are some other ones, but it doesn't really matter. This one will do just fine. That's what we want. And there you go. So it runs. So this is how code blocks looks in Linux. Now you will remember it because you will see exactly the same layout in Windows. It looks exactly the same. There are pretty much no differences of whatsoever. So let me just go ahead and close it because I don't really need it here. If you're using, this is for RP, this is the way to install it on Fedora. If you're using Ubuntu or a Debian-based distribution, you can just type in apt-get install code blocks. This should work. It should work on pretty much any Debian system without any problems. If you're using some other Linux that's not using the apt-get or that's not using the DNF, you can just type in the command that is used to install basically here, and space install space code blocks. It should work without any problems. Keep in mind that you can also pretty much use the same procedure as you do on Windows for Linux as well. You can just download it from the net and run the file. So that's also an option. Okay, so let me just move this terminal away onto my other screen. And here is a Windows setup. So Windows setup is also fairly easy. Let me just go ahead and expand this across the full screen. Okay, so let's go ahead and open up Firefox. And let's type in code blocks. Fairly simple. Open up the website. It's gonna be the first one. If you type in code blocks, chances are that it's going to be the very first one. Okay, so you have a lot of documentation here that you can read about it. That you can read if you want. No big deal. Go into downloads. We would like to download the binary release. You can also download the source code if you want to examine it. And here you have, like, I don't know, if you're a Mac user, just go ahead and click on Mac OS X. It's going to drop you down, and there you go. That's the file that you download and that you run, that you don't actually need to do pretty much anything else. What is it? Code blocks. Okay, so you don't really have the latest one for Mac. But yeah, they're looking for Mac developers. So if you feel like you want to do it, you can apply. It's out there, you know. It's very good. It's very good learning. The best way to learn, actually. But anyway, that doesn't really matter now. So you see, you have also for Linux 32-bit and Linux 64-bit, whichever one you want. And you also have, since this is a demo for Windows, you also have here for Windows. So you have Windows XP, Windows Vista, 7, 8.8, 8.1, and Windows 10. Okay, so just go ahead basically and click on it. And here you have multiple choice options again. So let me just see, which one do we need? We need the one with the min.gw compiler, which is going to be this one, setup exit. So just go ahead. So once again, look. It's this one. I am selecting it. Don't miss it. So if you download something else, chances are that you're going to encounter problems. So it's 1, 2, 3, the fourth one from the top. And then you go ahead and click on sourceforge.net. It says download of code blocks will start in like 3, 4, 5 seconds, whatever. Excellent. So you have chosen to open code blocks, exit, okay, save file. By the way, let me just tell you that when downloading exe files from the net and running them on your PC, make sure, I mean absolutely make sure that you trust the source of your download and that you trust the developers of that program, especially when downloading closed source applications. CodeBlocks is not a closed source application. It's open source application. You can actually download the source code itself and have a look around if you want. No big deal there. But I'm just saying that when you download exe files, doesn't matter if the course is mine or someone else's, or if you're looking at a YouTube tutorial or whatever, and when somebody says, okay, now you need to go to this website, download this exe file and run it on your PC. Like, don't take that at face value. Like, think about it a little bit. Examine the source, where you're downloading it from. What are you downloading? Don't just download exe files and run them on your PC. It can cause you a ton load of problems. So just go ahead and click on this, or go into downloads basically and run it. Yes, it doesn't matter which browser you're using. I personally am using Firefox. I really prefer Firefox across all of my devices. So welcome to CodeBlocks setup. Next, I agree. Okay, so all these things need to be selected. Click on next, install. And it's going to run. So now you can just leave it and let it roll. Eventually it's going to get there. The installation process is surprisingly a little bit slower on Windows, probably because it's a virtual machine and it is not as fast as my main machine. You can see that the icon appeared in the upper left corner as well. Excellent, so it's gonna finish. The beauty of it is, as I said, is that it comes with a compiler, so there's no need for linking or any of that, or any of those complications that come around with Eclipse or some other IDE. Although I do prefer actually Eclipse for when I'm working on a project or something like that. It does come with a good amount of options. So, do you want to run CodeBlocks now? No, thank you. We shall run it when we're done. Okay, click next, finish, close. Yep, there we go. So it's done and over with. And what I wanted to say is that CodeBlocks, not that it lacks options, but it's probably one of the best development environments for learning. Probably the best. And you can also do some very serious work in it. So let's go ahead and open it up, run it. Anytime. There you go. So look, let me just go ahead and minimize the virtual machine. And let me go ahead and run CodeBlocks here. Okay, so do you notice the similarity? It looks pretty much the same, right? So this is Linux and this is Windows. So the development environment looks the same, and it's going to look pretty much exactly the same on a Mac as well. So you don't need to actually worry about that either. There are no problems there of whatsoever. It's all pretty much the same. The development environments and the installation procedure is also fairly simple. There aren't pretty much no complications with it. So let me just go ahead and expand this to full screen. If you want to create a new project, you just go. This is just a very, very, very basic side. As we progress through the tutorial downwards, and as we go into more complex stuff, as we begin learning, etc., I will introduce the various options in CodeBlocks. But I just want to show you how to create a project. So you just go ahead and click on File. You go into New. You go into Project. You click on Console Application. Click on Go. Next, select C. Make sure that C++ is selected here. Next, whatever you can name your project. I'm just gonna name mine Test for now. You can select the folder where you would like to save your project. This is arbitrary. I mean, wherever you save it wherever you want. It makes no difference to me. I will be doing my saves on desktop because I will delete them later on anyway. And go ahead and click on Next. You don't need to change anything here. Just click on Finish, and you will get your first C++ project. This is a generic thing that's generated by CodeBlocks, can be changed. Main is here. What all of this is, how it all works, all of this will be explained. Now, another key thing is that if you want to, like, for example, delete a file, actually, if you want to delete a project, it's a bit strange. You first need to go ahead and go into close project and then go into the file, like here, wherever I have saved it. Chapter 4 code blocks. I have no idea where I've saved it. Let me just go into properties. C users desktop chapter 4 loops. Okay, I seem to have used a previous folder. Okay, so yep, it's right here. So look, if you want to delete this project, you need to first close the project and then find it in the file system. So mine is here, and then delete it. The reason why you see chapter 4 loops, we're gonna get to that, is due to the fact that I usually cast at least like 50% of the course or something like that, and then I come back and make the intro for the course and setup. I don't know, I just find it easier that way, but hey, you know, many people and many different tastes and ideas. Okay, so now that you have your integrated development environment set up, configured, up and running, I am going to go ahead and bid you farewell here and hope to see you in the follow-up tutorial where we will actually start coding. Welcome back. So, let's go ahead and begin with the very first C++ program. It's not going to do much. In fact, it's not going to do anything. But in this chapter, we will write a C++ program to show what each C++ program must contain. You might find it a little bit surprising just how little is actually needed for a C++ program. We will see how to later on within the confines of this chapter. We will see how to write to standard output, how to declare variables in C++, and their memory representation. But for the time being, let's go ahead and see what a C++ program must contain. So this is the bare minimum, nothing but the mandatory things. Let's just go ahead and pop code blocks. Come on, my good man, come on today. Okay, so file, we're gonna go ahead and create a new project for this particular chapter. So just go ahead and select the console application, go. Next, yes, we will make sure that it's C++ and not C. Project title, chapter 1. Okay, so you can change its location here. I've just placed mine on the desktop. It doesn't really matter to me at all, but you can place yours wherever you would like to place it. And go ahead and click on next. This is all fine and dandy. Just go ahead and click on finish. So if you go into sources, main CPP, go ahead and open it up. You can delete this. In case you don't have the main CPP, you can just basically create a file. I do believe that I've demonstrated that in the very beginning chapters, but you will always have this template in code blocks anyway. It doesn't matter. Main.cpp is just a file. It can be empty. It can contain some code depending on how the templates are configured. So code blocks does give us the basic program, but I've deleted it just to show you what the basic one actually needs to contain, because what code blocks gives you is a little bit more than the basic C++ program. So I'm just gonna press enter a couple of times for the sake of aesthetics. No real technical reason for it. And if I type in int main, okay, press enter, open, close. This is it. This is the C++ program, the very basic one. It is a valid C++ program, and it cannot get smaller than this. This is the smallest possible C++ program that you can make, in my opinion. Anyway, I mean, if somebody else can make a smaller one, please send me a private message or something like that, and I would love to see it. But I'm pretty sure it's not possible. Anyway. That's it. This is a valid C++ program. It doesn't do anything at all, and if you build and run it, nothing will happen and the program will simply stop executing. We will, later on along the way, we will explain what each line of the code does through our examples. But for now, you have to keep in mind what we have learned in this chapter. It might not seem like we've learned a lot, but believe me, it is very significant. Probably the most significant thing you will learn about C++, because without it, you won't be able to move anywhere in C++ world. So, each C++ program must have a valid entry point, meaning main function. What functions are, etc., that will be explained along the way. But for now, just take my word for it. Every C++ program must have this entry point. Must have an entry point. And that entry point is the main function. This is how things are. And later in the course, you will see what functions are and how they work. Now let's go ahead, build and run the program. So build and run up here. You can go ahead and click on it. That's it. Now, depending on the development environment that you are using, the integrated development environment that is, I'm using CodeBlocks as it is the simplest one. CodeBlocks will always pretty much do this. It will pop this terminal and then it will hold it open for you so that it doesn't close. If you were to, for example, run this in Eclipse, it would behave in a different fashion. If you were to run this in NetBeans, again, it would behave in a different fashion. If you were to compile and run it from the CMD, again, it would behave in a little bit of a different fashion. You see, each environment adds something of its own. But as you can see, absolutely nothing happens. There is nothing printed out onto the screen. The program does nothing, etc. Let's just go ahead and close it. And this is basically it. That's what you need to learn. This is the very first thing that I wanted to teach you, what a most basic C++ program looks like, that it works. Bid you farewell, and we shall see each other in the next chapter, in the next tutorial. Welcome back all. Today we're going to go ahead and jump into a next chapter. So we're still sticking to some basic stuff, and today we're going to have a look at interaction with the user. So we will attempt to make some sort of an interactive program. Basic as it may be, it's still a form of interaction between the user and the program itself. So in this particular chapter, I will show you how to input values from a keyboard. We will also talk about some advanced things regarding variables and their declaration. Our first example will illustrate basically how to write a program that prompts a user to enter an integer as an input, and then, I don't know, outputs a squared value of that number or something like that. Doesn't really matter. So let's go ahead and create ourselves a new project for a new chapter. So just go ahead and go into new project, console application. Next, make sure you select C++, click on next again, and let it stay on. I'm going to let it stay on desktop, but you can basically put it anywhere you want. And I shall be naming this one, I don't know, we shall name it, oops, sorry, my bad. I've just messed up my notes, but it's okay. Let's just call it interaction with the user. So, oh god, I can't. Interaction with the user. Hopefully I've spelled that in a proper way. Go ahead and click on next, finish, that's it. Plus on sources, main CPP, and already you are given this template. At a certain point of time, we might actually be using a template or creating our own, but for the time being, we will be typing everything ourselves. We're not skipping one thing at all. Okay, so let's begin with the inclusion of a library from whose resources we will need. And on top of that, let's go ahead and do a bit of a zoom in as well. So include, and here we shall include IO stream, so input output stream. Down below we will go ahead and declare our main function. main, do this, give it a scope, and now let us begin. Type in int number semicolon. So first of all, we are declaring a variable number of type int. This variable will hold the user input. Next up, we will type in std. So we will use something from std namespace, cout, insertion operator, and we will write something simple here like enter an integer. Excellent. So let's go ahead and close it. Line terminator, and with this we are going to prompt the user to enter an integer. Basically, this is going to get printed out onto the screen and say to the user, hey, enter an integer. Very well, but now we need a method for accepting what the user inputs. Again, we will use something from namespace std. Type in std : cin, and we will do greater than sign number. That's it. So input from the keyboard, and this greater than sign is basically the opposite of lesser than sign. It is called and referred to as extraction operator. It extracts the value from a variable. So you have std : cin, which represents our standard input from the keyboard, and then puts it into a variable number. So we will accept some sort of an input from the keyboard, and then we will use the extraction operator, and then we will place that value within the variable number. Anyway, so cin is basically short for character input. So C character in input. Simple as that. No big deal there. Okay, so now we are going to go ahead and square that particular number. Let's go ahead and declare a variable in which we will store that number. Squared equals number. Basically, this is a square. This is like, yeah, just 1 times itself. Simple enough. I don't think I need to explain what a square of a number is. Semicolon here. Now we have declared a variable squared here. I have only named it squared. It is up to you, as I've explained it before, to name variables pretty much whichever way you want, but it is a standard and a good programming practice to name them in some sort of a meaningful way. So I have declared this variable, and directly I will assign the result of multiplying two numbers, or I'm multiplying one number by itself. You have an asterisk sign in between, and this is a binary operator. So this is the asterisk sign in between, which is a binary operator and is used for multiplication. Keep in mind that the value of the variable number has not changed at all. We have simply multiplied it by itself, but we haven't stored this into number. We are storing this into the variable squared. So the value of the variable number still stays the same. No change there. Okay, next out. std : cout lesser than sign. Squared number, quotation marks, of course, and we're going to do this. We're basically just formatting the output onto the screen. We want to make it as pretty as we can so that people can actually read it. And we're going to do this a bit unnecessary. All of this could have been placed in one line, but it's okay, fine, no problems. And we're gonna go ahead and do this again. Now we shall insert a variable here. Squared, do this, std : and L, meaning we're going into the next line. Endel is not only used to go into the next line, but it flushes the current buffer. It empties it completely. That's why you also use /n, which is a character for a new line. But in a lot of cases, it is better to use endel as it's a buffer. It's a buffer. Basically, it just flashes the entire buffer. There's nothing that remains in it. So this will print out the squared number. Down below, we can again use std cout, which will be, of course, printed out in the next line due to the usage of endel. Squared number. Okay. Lesser than sign. Number. Here we're using the variable number whose value is going to be placed here. And let's go ahead and type in is space do this number times number, because you can also perform operations here directly. You don't need to perform them separately from this. And in such a way, we would actually save ourselves the trouble of declaring this variable to store this value. But if we do it like this value won't be stored anywhere and we won't be able to reuse it later. Well, anywhere is a relative term, but I'm just saying that we won't be able to reuse this value elsewhere unless we store it into some sort of a variable. And now we can basically just do this. I don't want to do it like that. Let's just do it here. And L semicolon. Excellent. So this will once again print out the square number. But we can directly print it out. We cannot directly print out the squared value without declaring the value squared, as I said, because then we can actually store it. And once this squared value is stored within the variable squared, then it can be reused elsewhere in the code as many times as we want. We won't need to type in number times some number times some number, and then calculate that every single time. So not only do we actually save space like this, but we also save the processor time, because if we were to do this every single time, we would occupy more processor time than we do it like this. So we just multiply them once, we store them into a variable, and then we reuse the variable on end later on to our heart's content. But if we needed the square number of this particular variable, then we would need to multiply it every single time down the road without actually storing it anywhere. Anyway, I'm pretty sure you get the idea. If you don't, the discussion section is always open and most welcoming to you. Now, at the end, we shall type in return 0 semicolon, and let's go ahead and end this. Have I done this? Yes, okay, it's already there. No big deal. So let's go ahead and run our code and see what actually happens. Okay, build and run. Oh, there's a problem somewhere. What could it be? So it's stating that it's on this line. Oh, right. Endel was not declared. So std : : There we go. Let's go ahead and run it again. And there you go. It says enter an integer. 10. So square of 10 is 100. Press enter. There you go. Square number is 100. I seem to have an extra space here, but no big deal. We can fix that rather fast. And square number 10 is 100. Okay, I could have written this in a better fashion. The square of a number 10 is 100 or something like that, but it really doesn't matter. I just wanted to make a point here. So now let's go ahead and make this short fix where there's an extra space, and it's right here. Square number, this number squared is this number this number squared is, and we shall do this. I don't even know I wrote it like this originally. So this number squared, this number, okay, let's put it like this. This number and number squared is blah, blah. Let's go ahead and do this. Again, so this number squared is 100. This number 10 squared is 100. There we go. Okay, there we go. So this number squared is 100. This number 10 squared is 100. Really irrelevant. This is just the formatting. I just wanted to show you these two main things here, that you can perform some sort of an operation, get a result, store it into a variable, and then recycle that variable later on, use it in the rest of your code. For example, print it out like this, or you could actually do the math immediately in the printout, in the printout statement, and we would actually get a value from this, and this would get printed out onto the screen. Anyway, I bid you farewell, and I shall see you in the part, in the next part, in the next tutorial of this mini chapter. Welcome all. So today we're gonna go ahead and begin a new chapter. So in this chapter, we will talk about I will basically be demonstrating some more advanced examples. So we will talk a little bit about the inclusion of other libraries, what that actually is and what that stands for, logical operators, relational operators, and then finally we will dive into the if-else statements, conditional execution, and operand combining, and the combination of operands. So you will see what I mean by this soon enough, but for the time being, let's go ahead and begin with the inclusion of other libraries. I'm just going to go ahead and quickly create a project. Hopefully you know this, you know how to do this by now. Project title, how shall we name this? I don't know. I'm just going to name it Chapter 3. You can name it however you like. I've just told you the list of subjects, so name it, give it a convenient and appropriate name for you, so you can come back later to the code and know instantly what it is. I'm just gonna go ahead and click next, finish. Thank you very much. Main. I'm gonna delete this. I know I can change the default thing that the code blocks outputs, but I'm a very lazy person in this regard, so it's actually easier for me to, I've deemed it easier to delete it every time as opposed to permanently change it. Anyway, not that used to using code blocks, but it is a good ID for learning. Anyway, so let's go ahead and see how to include libraries, as well as the basics, as well as some other basics in regard to that. So we've already seen this. I mean, nothing new, right? Include IO stream. So we've basically included a library. So when including these libraries, we must place them in lesser than and greater than signs. So in between them, we basically just include a library. This is a library, what I've selected. Down below, you can go ahead and type in string. So string, same. Again, no big deal, no difference. Anyway, in C++, there is no need for adding a .h extension on system libraries, which is the case in C. So, I don't know, in C, for example, you would have something like this. Include, and you could have, well, time time .h. So this is still this should still be valid here. However, this is not something that we do in C++ in general, not like this anyway. If you have these things, you would yep, my apologies, you would actually put this into quote marks, and that would be time.h, like that. So, but we're not gonna do that now, not yet, and not in such a way. Also, because C++ is compatible with C, there is a special syntax and naming convention for including libraries, and you would just use the C name of the library, and without using the extension. For example, I don't know, this is what you would do without the quote marks, or without pretty much anything in C++. We can just do this. I've shown you time a moment ago, and we would do this include C time. There you go. So that's how you would include time without actually doing this. So this would be a C format, and this would be a C++ format of the same library. So no big deal. In general, the rule of the thumb, so to say, if you have a library in C, and if you would like to use that same library in C++, if it exists, I mean, it's compatible, so there is a compatibility between the two, and you should generally be able to use it. You would just use it like this. So include, and if the name of the library, let's just invent something and say abc.h. So this is in C. If it's like this in C, you would just need to do some slight alterations and make it C++ compatible. So you would just place C in front of this, and you would delete the .h. So this would be the C syntax of the same library, abc.h, and it doesn't exist. Well, maybe it does, I don't know, but I've basically randomly placed letters here. And if you would like to include that same library in a C++ program, well, you would just place C in front of the name of the library. I'm sorry. Oh, God. You would just place C in front of the name of the library, and you would remove the .h. That's quite literally it. There is nothing too complicated. Nothing too complicated about it. Anyway, here's just a few examples, no big deal. So include std lib.h. This is C, and include C std lib. So this is C++. Down below, we can type in include time.h, as I stated before, and up above you have C time. So you have time.h, which is C, and C time, which is C++. Now, there are also non-system libraries that can be included by stating the path of the file inside the double quotations. So for example, you could have this. Include, quote marks, some lib.h. Now this is not going to compile because sumlib.h doesn't exist. And if it does exist, then okay. But if it does not exist, then it's not going to compile. This means that the library sumlib.h is located in the same directory as the file that includes it. If this is not the case, so if this is not the case, if this library file is not exactly in the same folder, you see I have chapter 3 here, and it says here chapter 3, okay, main. So if it's not in this folder, if that .h, what did I name it? Sumlib. If sumlib.h is not located here, the program will not be, it will not run. It will not compile. That will be a major problem. However, If it's not located there, but if it's located elsewhere on the system, you are given an ability to specify an absolute path. So path to the file. And you can specify an absolute path, and then it will run, then it will be combined. So there's just one more thing that I would briefly like to mention, perhaps not the most important thing of them all. It's basically what happens when we include the same library multiple times. For example, if I have included string here and I don't know, include it again. So include string. So like this. In that case, compile will ignore every other include except the very first one that was made. So it's a very wasteful and shameful programming practice, but no big deal. It happens to everyone from time to time, so don't worry about it. It's not a major problem. It's actually not a problem at all. As I said, compiler will ignore every other include except the very first one that was made. So we have learned the way the compatibility in between C and C++ works. We have also learned that you have system libraries and non-system libraries. For non-system libraries, unless the library is in that exact same folder, it will not run unless the full path to that library is given. And this is this is the syntax for including non-system libraries. And up above, you have syntax for including system libraries as well. This is for C and this is for C++. Again, C, C++, etc. I bid you farewell, and we're gonna go ahead and jump into the next tutorial where we will go ahead and take a look at the types of operators. Welcome back all. Today we're gonna go ahead and jump into a chapter that will deal with loops in C++. Now in this chapter we will learn 4 different types of loops: for, while, do while, and for each. So we will also learn another one, the so-called goto loop. Keep in mind that I've said this, that I take this with a grain of salt, let's put it like that. Not exactly a loop, but not exactly a not loop. However you wish to look at it. As I said, we will learn the so-called goto loop, which can be used for the simulation of loops. Now, loops as a general concept is present in pretty much all programming languages. They all pretty much use loops in order to perform repetitive tasks. Like you have a chunk of code which you would like to be repeated over a set number of iterations, and therefore you just go and use a loop in order to make that possible. So as I said, it's just a concept that is used widely across pretty much all programming languages, but here I'm going to go ahead and show you how you can use these various types of loops in C++. The for each is also is primarily for C++ 11. So I'm just going to go ahead and create a new project. You might notice that my taskbar is gone down below. Well, I didn't really need it, so I just hit it. Let's hit it down below. It should pop when I touch the bottom with my mouse, but oh well. Anyway, console application. This was, by the way, completely irrelevant for the course. Let's go ahead and click on next. C++. Sure. This is going to be chapter 4. That's how I'm naming them. You can name them any way you like. Chapter 4 loops. Okay, so next. Finish. Excellent. Oh, one of these days I'm gonna fix this. I don't think it matters that much, really. Come on, zoom it in for me. Thank you very much. So let's go ahead and start. Let's begin with one example. We will write a program that prompts the user to input a number n, and then asks the user to input n numbers. In the end, it basically just outputs the sum of those numbers. So it might seem a little bit confusing when I put it like this, but you will see it is extremely simple. So just go ahead and include IOStream, so input output stream, the library here, and that's it. Int main, and go down below, int n. So this, int n. This will be our integer variable that will hold the number that the user enters as input. Okay, so shall use from the std namespace cout and enter n. Okay, no need for the next line. We want it all to be in the same line. See, we have a semicolon and then a space, and then we'll be able to enter a number. And down below, std colon cn and n semicolon. Hopefully by now you know what these are, like the operators. Anyway, semicolon here and n here. That's gonna. We have instructed user. Hold on. We have instructed user here. Here we've told the user basically, hey, do that. Enter. So we've told the user here to enter a number n, or just enter n, and down below, well, enter int n. Let's put it like this, so that the user knows it's an integer that here he needs to input. Anyway, and down below we have provided a method for the user to actually be able to input whatever has been asked of that user, to basically input that integer. Anyway, we will go ahead and need to declare a variable called sum, so 0 here, and we need to initialize it to 0. So it must, and I mean it must in this case, be initialized to 0, as it can cause some serious problems if it is not initialized. The compiler is not going to report any problems. However, it'll be one of those logic errors on the user's end, and you might not get what you wanted to get. I will explain why in a moment when we actually get to that portion. Well, typing today is amazing. Anyway, for. This is going to be an example of a for loop. So int I, we can declare another variable here, and that variable holds and is declared for the scope of the loop. Beyond the loop, it is not known. You can literally declare an I again outside of the loop without any problems. However, once declared outside of the loop, then it's a completely different matter. Okay, so it's lesser than or equal to n, and it's going to be plus plus I. Okay. So our loop, it's going to start from 1. I stands for index or iterator, or however you want to call it. You don't need to use I. You could have used pretty much any name, any legit variable name here instead of I. So it's not a big deal. But general standard practice is to use I, J, K, and those 3. But you can use pretty much whatever you want. It doesn't matter. So you can tune it to your convenience. Let's put it like that. Anyway, our for loop, it starts from number 1. So I has been initialized to 1. We could have initialized it to whatever we wanted to initialize it. It really doesn't matter. And then it goes to n. I will continue to increase here until this condition is satisfied. So for as long as I is lesser or equal to n, this here will evaluate to true, and therefore whatever is within the body of the loop, of the for loop, will execute or keep executing over each iteration. Once this condition here becomes false, then whatever is within the body of the loop will cease, and the loop will itself terminate as well. Of course, this is if we input 10, for example, I is 1, so 1 is lesser or equal to 10. Yes. Okay, iterated by 1, and I don't know, do whatever else we tell you to do, basically. But eventually, over the course of iterations, I will become 2, and then it will become 3, 4, 5, 6, 7, 8, 9, 10, and then it will become 11. And 11 will no longer be less or equal to n. So this number n is basically the amount of repeatances for this loop. Within the loop, we shall declare int number std : cout, and we shall do this enter. Let's put a semicolon, why not? I dot number semicolon. There we go, it's closed. And let's provide a way for the user to actually input something. std : previously I've stated like let's provide a method for user to input something. I mean methods are something completely different in C++. We will get to that. It's just a way of my expressions that can be a little bit confusing, but just provide a way for user to basically just input something. So get that number. And what will happen here is that the loop will repeat for as many times as we have specified with the n here, which the user basically inputted. And down in the loop, on every iteration of the loop, the user will be prompted to enter, oops, sorry, not I, n, number. My apologies. On every iteration of the loop, the user will be prompted to actually enter a certain number. And that number, the way for inputting that number has been provided here. So every time this loop repeats, the user will be prompted, okay, please enter a number, and you will see it will be printed out on the screen every time we actually input a number, depending on how many times we have specified that we want the loop to repeat itself. And now we come to the point of sum. And I will show you here and demonstrate why, actually just show you why we needed to initialize sum to 0. It's rather simple. So let's not use this format here. Let's just put it like this. And I'll tell you why. Okay, so sum. We have declared it here, int sum. Now imagine if we didn't actually initialize it to anything. What does that mean? Well, a variable sum would have been created and it would have occupied a certain space in RAM. So whatever was in that space prior to the creation of this variable would become the content of this variable. And then when we would get to this point here, the content of that variable would actually be, to that content, this number would have been added. So we would get something completely different other than the sum of numbers that we wanted. So just imagine that you had some like 0x and some random things here. Well, there are no U's. And just some random information here that has been, I don't know, perhaps a variable from the previous program or something like that, etc. Some random value. That would have been a problem, because then we would be calculating the sum of a certain amount of numbers, and we would have been adding that random value to that sum. Therefore, that sum would not be accurate. Therefore, we have ensured that mistake will not happen by simply initializing the sum to 0, the variable sum to 0, and therefore everything will just be added to 0. There will be no third-party values that will be added that will factor into our sum. Anyway, there's no need to write it like this. This is the long version. You can simply do this plus, and there we go. So this is basically the same as what we have just written. So sum equals sum plus number is the same as sum plus equals number. Exactly the same things, just written in a different fashion. I would always advise you to use this format it's just shorter to write, and it's quite easy to comprehend and understand for anybody who knows what they're looking at. Okay, so let's go ahead and type in std : cout and sum of n, I don't know, n numbers, or I don't know, we'll just place n. Okay, numbers is, gotta love my notes, sum std colon colon and L and semicolon. Okay, sum of n entered numbers is, and then of course the sum, and there we're gonna go and move on into a new line in order to make this simpler. So let's go ahead and type in return 0. Do I have it? Nope. Return 0, and let's go ahead and see what happens. What's gonna transpire here? There's gonna be an error. That's gonna be the first thing that happens. I wonder what the problem is here. Okay. There is a semicolon, my good man. Why are you reporting that there is a expected semicolon before string constant? Let me just take a look at it. Main CPP line 7. Is this a semicolon? Yeah, it certainly looks like it. Yep. stdc. Oh, right. Okay. I'm seeing the operator here. Okay, there we go. So it says enter int and enter in 10. I don't know. Let's say that it's 10. And now we have some random number that we need to enter. And this is exactly what I was talking about. It says here, enter. You see, it says enter and then number. Have I initialized number to anything? No, I have not. And yet there is this strange value here. So it's just a random thing from memory, no big deal. Instead, we shall change this in order to make it a little bit different. We don't need to initialize the number here because the number will be initialized here once the user makes an input, but we can tell the user which number in line do we want him to enter. So enter first, second. I can't actually. It would vary from. I wanted to write like first or second, third, fourth, but no. I'm just gonna place a dot there and I. And now we're gonna take a look at this. So enter n, then enter first number. Okay, so that makes sense, right? It says here enter first number. Let the first number be 1. We can also enter same numbers, 2, 1, 4, 5, I don't know, 10, 11, 12, and 13. I don't know. Let's add it. So the sum of 10 entered numbers is 60. There you go. The program ends. Let's see if it's indeed 60. 1, 2, 4, 5, 9, 14, 24, 35, 47, 50, 60. Yep, there we go. So it is indeed 60. If you don't believe me, you can just go ahead and calculate it yourself or use a calculator or whatever in order to figure it out. So let's go ahead and do a bit of a recap. There are some things that I do need to explain. For example, this part here, actually, let's just use some pseudocode here. I just want to make sure that you understand this for loop as it is very important. You have the initializer. Oops. And then you have the separator here, and then the condition, and then the increment. Down below, you of course have the body. That is, the body is basically the code that's going to get repeated, that will get repeated. So the initializer, this is our initializer here. The condition, this is the condition here. And you have the increment, and our increment is here. Let me just go ahead and talk a little bit about the increment. I've already explained that whether the loop will continue or not depends on the condition in the center. And that condition will eventually change from false to true because the initializer is changing, which is the integral part of the condition. the condition is dependent on I actually being less or equal to n. And since the value of I is continuously increasing, it is safe to assume that at a certain point in time, I will become greater than n, and this condition will evaluate to false. Anyway, increment, this last part, it controls the loop steps. That is, in each iteration, the variable I is incremented. Now, in this particular case, it is incremented by 1, and we could have written this in various formats. We could have written I equals I plus 1. This was also one of the possibilities. I mean, we wouldn't actually change anything, and we could have also written this 1. So you would usually use this format if you wanted to add a number that is greater than 1, but if you just want to add 1, you can use I plus plus or plus plus I. They're all pretty much the same. However, if the loop variable is being incremented by 1, this is a preferable thing. Let's put it like that. Keep in mind that I plus plus and plus plus I is not the same in expression, but inside the for loop it is. So if you use this in expression like plus plus I and I plus plus, these would be two different things. However, if you use it in a loop, in a for loop here, it is it doesn't matter. It is pretty much the same. Furthermore, we can also use the control variable I inside the loop body, as I stated in the very beginning. In our example, we ask the user, for example, to enter the first and then the second and then the third and then the fourth. This is very useful because this is incrementing anyway right here, and we can tell the user actually which number to enter. So I bid you all farewell. I ran out of time, and I hope to see you in the follow-up tutorial. Welcome back. So today we're gonna go ahead and begin a new chapter. In this chapter, I will envelop the basics of arrays. So that's one of the concepts which I have introduced in the previous chapter. Just briefly, I've mentioned it. But let's go ahead and take a look at what arrays really are, because you will be dealing a lot with them and you will need them for a lot of things, believe me. Anyway, so as we introduce arrays in C++, let's go ahead and say what they actually are. So arrays, by definition, are basically data structures that contain a number of easily accessible elements of the same type. Now here we will talk about one-dimensional arrays, but we will cover advanced part in later tutorials. So the concept is basically to have all these elements stored in a sequence of some sort and then be able to access them by some sort of a reference. So very often we are required to group a number of variables of the same type into one logical unit. So for example, like student grades, cars, some numbers that represent some parameters, etc. So if you had student grades, you would need them all to be in one logical unit, which an array can actually provide you with. So arrays are basically homogeneous data structures because all elements are of the same type. So let's go ahead and dive into the very first section here. So let's just go ahead and new, yes, project, console application, go. Really should click skip arrays. Okay, next, finish. So let's have, actually now this is becoming somewhat useful. I'm gonna remove this and this. Anyway, in declaring an array, you would require a following syntax. I'm sure that it's relatively familiar to you. You require to define a type, and then you need an array name, and after the array name you would need a size. So size is a relative term, as it doesn't necessarily need to be defined here. You can simply initialize an array to a certain amount of elements, and that is going to define the size as well. So what we want to do is, this was pseudocode, so let's just go ahead and clear an array. So this is just a declaration of an array. This is without the initialization. ARR1, let's call it like that. The size of this array will be 10. So it has the potential to store 10 elements. None of these elements for the time being are initialized. So I can do this as well. Float ARR2. Let's go ahead and give this one a size of 3. So this is not initialization. We're just defining how many elements does array need to contain. And for this basic part, let's take it that an array does need a defined size prior to its usage. So you need to define the size of the array. There are ways of not defining, well, harsh word. There are ways of not putting a fixed number here and actually have an array that is dynamic. So, but this will be done later on in the advanced parts, because we're gonna need pointers, and trust me, at a certain point of time you will need arrays whose sizes are not fixed, whose sizes can change and alter. So you can basically store, in theory, an infinite amount of elements. Anyway, so something scalable, let's put it like that. But that's all for later parts. For the time being, just take it that arrays do need to have fixed sizes. And that's how they're usually used in the very beginning of things. And later on as well, people tend to put fixed sizes as well. So each element of an array can be accessed via a particular index. But we have to be careful, since the indexing in arrays, I remember mentioning this somewhere along the merry way, that indexing in arrays starts from 0. So the first element is not indexed with 1. It is indexed with a 0. So if you will go ahead and do initialization to demonstrate this, so let's go ahead and do it like this. ARR1, element 0 shall be 5. So this is the first element of the array. You don't need to initialize them in any particular order. You can initialize them in any order you like. So ARR1 again at element 4. Element at position 4 at index 4, sorry, not element 4, element at index 4 shall be equal, I don't know, to 10, let's say. And element at position 9 shall be equal to 100, let's put it like that. So this is basically the last element. Why? Well, because indexing begins at 0, so let's count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 numbers. So the size of the array is indeed 10. Anyway, it is also important to mention that the compiler won't warn us, nor it can, if we access memory locations that are outside the range of our array. So these locations are called pits, basically, and they are not easily detected because the program can run out in 8 out of 10 cases, basically. Because the program can run in 8 out of 10 cases, sorry. And in other 2, it doesn't actually run. What do I mean by this? Well, if you have an array 1 and it has a size of 10, and if you try to access like the 50th element of this array, which basically is outside the bounds of this array, the program, as I said, it's going to run in 8 cases out of 10. And it's not going to warn us, and it's going to be a problem because it's going to read something from a memory location, and it could read some sensitive information. That's how the overflows occur. And it could also just read some random junk, which could cause a lot of confusion in our logic, because C++ in and of itself does not do boundary checking. So this is a case in Java, so you won't be able to achieve this in Java, but take everything that I say with a grain of salt. But as I said, this is not the case in C++. That's one of the beauties of the C++ language, because it allows you to do whatever it is that you want to do. There are no restrictions, restraints, or of whatsoever. So let me just give you an example that is out of range. So let's take the float ARR2, whose size is 3. So 0, 1, 2. That's it. And if we say that ARR2 and we are trying to initialize like element with index 3, 11. So ARR2 has 3 elements. The last one is basically, this would be the last element. This would be the last element because it goes like this: 0, 1, 2. But we are trying to initialize the third element to 11. The program can run correctly, but it is ill-formed program, and it's bound to cause some problems because you do not know what's at that memory location. You could be overwriting something that is important to the functioning of your other programs or the system in general. So that can be a problem because something could be located in that memory location where you are putting this number that's basically important to the proper functioning of your machine, and you're basically deleting that and putting number 11 there. So when the machine needs to access those resources, it goes there, oh, I have a number 11 here, and it's supposed to be my pointer for a printer or something like that. Anyway, just be aware of those things. This is like the very wrong way of doing things, and if you're reading from these locations outside the bounds of the array, that would also be a very wrong way of going about things. So anyway, we're gonna cut it here, and we're gonna go ahead and begin the next tutorial where I'll talk a little bit more about the memory representation. It's gonna be a fairly short one, just something that I really need to demonstrate to you. Welcome back all. Today we're gonna go ahead and take a look at classes. So this chapter is an introduction to classes in C++, and it basically encompasses the principles of object-oriented programming. Classes, more or less, are just like structures. They're logical units. We have already worked with classes pretty much in the previous chapter. All the STL types are classes. Let me just show you the general syntax for a class definition. So if I type in class name, and if I just go ahead and type in, I don't know, int, well, actually, we don't have to declare anything here. This is just pseudocode. So you would have a list of attributes, and you can have a list of methods that is functions, and I don't know, you could place a lot of things here. We'll see through the example how it actually works. Keep in mind that anything declared here, just like this, without stating whether it's public, private, or protected, will be considered to be private and will not be visible outside of the class at all. So that can present a bit of a problem. And if I type in class here and then type in date, so let's go ahead and create a class date. I'll delete this, and let's say int day, and it's going to be int month, and we shall state that there's an int year as well. So if I want to access any of these variables, let's go ahead and create an object dt. I shall name mine dt, but you can, as in date, but you can name yours pretty much any way you want. And this object dt will be of type date. So I'm gonna go ahead and state dt dot day. Very, very, very similar to structures, if not the same in this regard. And we shall say that we would like to initialize this one to 10. This is going to cause an error, as day is considered to be private and cannot be accessed in this fashion outside of the class date. So if I just run this, you will see I will actually get an error, and it will state that date is private down below. In order for us to go around this, there is a simple fix to this problem. Perhaps not the wisest or the best of fixes, but it is a fix nevertheless. I can just type in public. I'm not really concerned with any sort of security or any interference here of whatsoever, so I'm just doing a demonstrative purpose. I'm just doing this for demonstrative purposes. If I type in public, semicolon, and then give a list of attributes down below, then this will be okay and this will compile. There you go. In essence, we've got a structure here. That is the only technical difference between a structure and a class. What you have just seen. If this was a structure, this would not have been a problem, but since it's not, it is. You have to make it public to access it from outside. Now, later we will make these attributes private, which is one of the fundamental principles of object-oriented programming, but for the time being, I shall leave them as a public. Now, if you're wondering how would you access them if they are private without putting them into the public domain, into the public domain here, so to say, well, you would basically create a method within a class date which would return one of these values. You would create a method whose return value would be, I don't know, year or month or day, and it would be able to pull them out. And that method would, of course, need to be public. You basically have two of them. You have methods that are referred to as setters, and you have methods that are referred to as getters. Getters would retrieve the values, and setters would set the values. But we shall talk about that some other time. For the time being, I'm just going to go ahead and wrap the tutorial up here, and we will continue on in the follow-up. I would like to introduce you to the principles of object-oriented programming. It is spelled OPP like this. I'm telling you how it is spelled because you're going to encounter a lot of this in the documentation if you read any, so I would like you to be familiar with the terms. Anyway, bid you farewell and hope to see you in the follow-up. Welcome back all. Today we're going to go ahead and begin a new chapter. So here we will talk about exceptions in C++. In essence, exceptions represent an efficient mechanism of managing programming errors. They were introduced in C++ 98, and unlike C++, C does not have exceptions, but rather instead it uses global error variables instead. This chapter will also cover standard exceptions, and in order for me to explain what exceptions are and why is it that we actually need them, it is best to take a look at an example and then figure it out from there, just to see why we would need them. So we'll basically write a function, sqrt, which will calculate the square root of some given number. I've already started code blocks here, and it's up and running. So I've also created a new project for this chapter called exceptions. I've decided to skip this part as I trust by now you know how to do that. Okay, so we will need a few things here. The very first one is basically include CMath. Yep, in addition to the iOS stream. And down below, we will go ahead and well, I guess we can create a prototype here and then create the body down below, but since we're going to use one single function, I don't think there is a need for prototyping and then defining it down below. Although if you have more than one function, go ahead and create prototypes and then define them elsewhere. Create the bodies elsewhere. So double sqrt double x. Okay, and so we'll need another double value. So we're going to name this variable sRoot. It's going to be std : POW. Now POW basically calculates the power of. It will, let me just go ahead and put it like this. If this is x, some number x, and this is some number y, what will happen is that it will calculate the x to the power of y. So this will give you a calculation x to the power of y. So we will leave x here, but here we shall type in 0.5. So x to the power of 0.5. And then we shall also go ahead and return sRoot. So return sRoot. There you go. So there are probably simpler ways to actually eliminate a variable from this, but no big deal. You don't actually need to like go through all of that at the time being. Let's just go ahead and write the program down below, and you will see how this relates to exceptions in a moment. We're gonna need double num and I don't know, std cout, enter number. I don't know, the user will enter some number of their choosing. std : seeing a lot. You wouldn't believe how many logic errors actually occur due to user input, because a user does not think in the same way that the programmer does. And you know, the programmer, if they enter an integer, they believe that everybody will enter an integer. So a stupid example, of course not, but just a stupid example. And then comes along somebody and types in a float, and that of course creates problems. Now imagine this, but on a more complex scale. Square root equals sqrt, and we're gonna have we shall pass to the function the variable num. So this is calling the function and assigning its return value to the variable square root. So you have a square root, and then this function will basically take the parameter num, and it will return a variable whose value will be stored into this variable. And we're just gonna go ahead and do a bit of a printout down below for our sake, so that we have an idea what is going on here. Okay, sqrt, so square root. If there is one thing that I hate doing, is basically formatting these printouts, because I've done so much of that, it's hilarious. You might say, oh well, that's great, you know, you got a lot of practice, etc. No. It's all the printouts are the same to me. It's just formatting it like this, formatting it like that, blah 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 blah. Because almost every example in these basic things, they have the cout printouts. So square root std and l. There we go. So this program will work perfectly if the user enters positive numbers. So let's just go ahead and run it. So much for running perfectly. Missing a semicolon there. Run it. Okay, I assure you it will run very soon. stdcin not declared. Okay. Okay, come on. Third time's the charm, as they say. Bang. Enter a number. What shall we enter here? Okay, let's say... So as we said, it works very good until the user enters positive numbers. So 1. 1, okay? Let's go ahead and enter like 30. Okay, still works. However, what if the user enters a negative number? For example, I don't know, -9 or whatever. We know that the square root of a negative number does not exist. It is not defined. So in that case, our square root function should in a way or in some way report some sort of an error. And this is where we will use exceptions. C had a global variable errno, so error number, which should be modified by a function and repeatedly checked. Unfortunately, that concept is outdated and is not good enough for most programs today. So our sqrt function should stop the execution if a negative number is passed to it. It shouldn't return anything. It should simply stop the execution by throwing an exception. to throw an exception, we use the keywords throw followed by the actual exception. So let me just go ahead and write some pseudocode here, and I will show you where the problem lies here. So for example, you would just type in throw, basically are throwing an exception. I don't know, negative numbers are not allowed. So there are of course other ways to solve this in this program. It's quite easy, but you don't need to use the exceptions to solve it. However, we will in this particular case just to demonstrate how exceptions work. Negative numbers. Or you can do this. Throw, and then you just give it a number. Or throw, you can do, I don't know, std : domain error. Negative, and then just type in like, I don't know, again, negative numbers are not allowed. Okay. I need a semicolon at the end of each one of these. Sorry about that. It's basically not pseudocode, but it's outside of the main, and this we're not going to take into consideration. Or you can even just do throw std : exception, and then you can just go ahead and copy this entire thing and paste it right here. So now we shall modify our function to throw an exception in case of an invalid parameter. But before we do, let's go ahead and see what happens. And before we see what happens, just take a look at these. These are formats of throwing exceptions. So I will show you how to actually do that in a program, but I just wanted to show you different formats of how this can be, of the syntax, that is. So let's go ahead and delete this, and let's go ahead and build and run this program one more time. And let's go ahead and pass -4. What? Square root of -4 equals nan. Okay, so in a way the program basically tells us that that something is wrong, but this is not really what we want. We want the program to tell us, hey, whoever you are, basically, let's give us we would like to know what is wrong. Tell me that I should not be allowed to pass a negative number. Okay. How shall we solve this? Well, as I said, you can solve it simply with a printout statement and with a cout and if. However, we don't want to do that here. Here we want to do something different. And basically, it's gonna look very similar to if, because we are going to use if. But in the if, we will use throw as well. So if x is lesser than 0, then I would like you to throw negative number. So just throw an exception that the number is actually negative so that we know that there is a problem. So our problem is now solved. The function will stop with the execution if a negative number is passed to it. All we need to do now is check what does stop executing actually mean. We will see that in the main function. So basically don't need any of this. We can leave it, but there really isn't that much much of a need. We can just pass the number ourselves in the program, so we don't have to bother with the input. So it's a little bit boring. And okay, so you can do a printout down below, but let's go ahead and do this, like -10. Let's just write -10 here. Okay, so build and run. What now? What? Error. Num was not declared in the scope. Okay. Yeah, I've just deleted it, so obviously. Just didn't notice it. Okay, there we go. No. Give me build and run. What do we got? What do we got? Exceptions.exe. Exceptions.exe has stopped working. A problem caused the program to stop working correctly. Windows will close the program and notify you if a solution is available. By the way, has anybody ever, if you've seen this message before when any of your programs crashed, did Windows actually ever notify you that a problem to the solution has been found? I mean, if you have been notified that a solution has been found, please give me some feedback. Tell me of your experience. Okay, so it says terminate cold after throwing an instance of char const. This application has requested the runtime to terminate. So keep in mind, this application has requested the runtime to terminate. Keywords, application has requested. So to terminate it in an unusual way, please contact the application support team for more information. Well, welcome to the application support team. How can I be of assistance? Close the program. Okay, so press any key to continue, and that's going to be the end of that. So basically, the program should crash, as it did. The function threw an exception, but nobody caught it. So we have an exception, but nobody's catching it. Now that is a good thing. If we pass an invalid parameter to the function, the program will at least crash. I mean, it won't run. So we'll have some sort of an error that we can see. So it won't be like a logic error on our end. It will be something to do with the machine. That the machine basically gives us some sort of a feedback and it crashes the program. It doesn't run. The worst sort of errors are programmer errors that are actually not reported or detected by the machine. So the program runs, it just doesn't do what it is supposed to do. Anyway, we've just seen how we've started this program and then it crashed and that's it, it aborted. Now that we know how to throw an exception, we need to learn how to catch it and control the program execution. So catch and control. This is called exception handling. Exception handling works as follows. The code that is supposed to throw an exception is placed in a special block, basically. It's called try block. The block of code will begin executing, and if the execution is successful, the program will continue working as was planned. But the try block is immediately followed by another block of code which is executed just in case the try block was not successful. The second block of code is called catch. So the catch block, it requires specification of an exception. So of an exception type, it basically is expecting. The pseudocode for this is not very complicated. It's actually quite simple. So we can write it onto the screen and then we can see what we can do with it. So you would have something like this. Try, and I don't know, right here. Try executing the code. So there will be some sort of code execution here that would get, the program would attempt to execute this code. But down below, it's going to be catch. And this would be type of exception. Never mind the highlighting now of the keywords. Forget about that. That's just me. That's just me using these keywords as a part of regular text. So this is basically exception thrown, type of exception, and then exception thrown. So the try block has failed. Now we're going into the catch phase. We're catching the exception. Okay, so this would handle the program in case try was not successful, exception thrown. So if try is successful, the catch block will not execute, so it will just remain there. However, if an exception is thrown, we enter the catch block in which we basically catch the exception and we gain a measure of control over the program, unlike here where we just threw an exception and the program crashed. Okay, so let's go ahead and see how that works in reality. we are going to go ahead and make a few modifications to our program here. So first of all, we are going to remove this from the function. Well, not, come on, don't do this to me. And we're not going to need the pseudocode down below. We're gonna delete that as well. And now we're gonna write just a bit of a longer code here to see how we can actually construct the try catch block and place code in it and see how it behaves. However, I'm really running short on time. It takes a bit of a time for me to actually explain these things. So I'll just continue in the part 2 of this particular tutorial. Welcome back all. Today I will introduce you to the basic concepts of generic programming. Now, the term generic is basically is just a characteristic of some sort of a group or class of things. It is not specific, so basically the opposite of specific. Here we will go over generic functions. These functions have the same body but can accept anything as a parameter, as opposed to the functions which we have been using previously, where you have specific parameters whose types are defined, and the functions can only accept parameters of those types. Here we will basically create functions that can pretty much accept anything as a parameter, which is a very useful concept. And generic programming is basically based on deduction or type-based parameters. Based on the parameter type, compiler will decide which function to call. There are two types of deduction. You have partial and complete. In complete deduction, we know nothing about the parameters, so nothing is known about the parameters. Whereas in partial deduction, there is some additional information. For example, we know that the parameter is an array, but that's pretty much all we know about it. Anyway, let's go ahead and take a look at the generic functions and type deduction. So that's really what I wanted to go over with you in this set of tutorials, or a tutorial, depending on how much time will I require to actually finish this. So let's go ahead and create a void function. Let's call it print, and we shall have int arr. Okay, so nothing new here really, and int len, so int length. Just a short version of it. Let's go ahead and prototype it and go down below and actually create the body of the function. Let me just Let me just go ahead and copy this. So as before, nothing new, nothing strange here. We're just going to go ahead and create the body of the function. So std, just going to go ahead and create a bit of a printout here. Yep. Okay, so there you go. And we're going to need a for loop, because this is going to be our beginning. You're going to have an opening of a bracket, and then we're going to have a for loop, which will print out all the elements, probably except for the last one, and we're going to have some sort of logic embedded there, and then at the end we're going to close it all with another block, like this one here. So here's what I am intending to do here. I'm just going to go ahead and say int I equals 0, and I is going to be less than length minus 1, and it's going to be plus I. We're not going to need any curly brackets down below, as we're just going to have one single line, and this will ensure that we basically manage to print out all the elements except for the last one. As you can see, it's length minus 1, or len, variable len minus 1, where len will be the size of the array. Since we go up to len minus 1, which means 1 lesser than the complete length of the array, we cannot access the we cannot basically access the last element And this happens when an array is we cannot access the element which is len minus 1, so we can't access the minus first element, so to say. Actually, I'm doing a very stupid explanation of that. Let me just go ahead and show you, like, through the code. It's kind of difficult to put it in words, as it's a fairly strange thing, so to say. So let me just go ahead and write it out, and then I'll explain it while you're actually looking at the code. I do believe that it's going to make way more sense that way. Okay, and okay, so this is going to print out the closing bracket outside the for loop and outside of the if. So look, we have opening bracket, opening block. It prints out all the elements of the array. So it prints out one element, and there's a comma, space, comma, space, comma, space, and so on and so forth. It goes until until I becomes equal or greater than len minus 1. And then down below you have len not equal to 0. So if the length is not equal to 0, if we haven't initialized an array whose size is 0, so if the length of the array is not equal to 0, then please create a printout after the for loop, which will go like this: arr len minus 1. So it will basically create the printout of this element here. Let me just put it like this. So it will create a printout of this element here of the array. Hopefully it makes more sense now with the if statement of what I was saying about a moment ago, and I was doing it in a really clumsy fashion. So this one here will not print out len minus 1 element of the array, but this one down below will print out element with this index. So element with this index will not be printed out in the for loop, but it will be printed out here. Okay, so now that we have that done, this is a regular function. Let's just run it. Well, we haven't actually called the function or initialized or passed the parameters or anything like that, but it doesn't matter. I just wanted to verify that the program actually compiles without any problems. Now in the main we can do the following. It shouldn't be that hard. We can have some sort of an array. I don't know, int arr, and okay, so I don't know, 2, 3, 4, minus 5, 1, 1, 0, ups, 0, 4. You don't need to type in the same values as I have. It's really not that important. And down below we're gonna have a const int len, because it does need to be a const. And look at what I'm about to do here. I'm about to type in size of arr divided by size of arr 0. So yeah, there we go. So size of is an operator which returns the size of an object in bytes. That is why we divide it by the size of an int. Yep, and down below we will type in print arr, comma len. So we're just passing the parameters now. Okay, no big deal. Oops, I seem to have made an error here. Equals, sorry. So we will initialize the size of len, so which will be the length of the array. with the result of these two here. So you have size of in terms of bytes of the first element of the array, and you have the size of the entirety of the array. So take a wild guess of what's going to get printed out onto the screen. Expected identifier before numeric constant. Well, of course, genius, it's a division. Okay, now you're confusing me. Seems to be the problem here. Expected a block before the comma token. Okay, there is a block here, and it is equal. Okay. Wrong. And let's go ahead and run it now. Okay, there we go. It says 2, 3, 4, minus 5, 1, 1, 0, 4. You see, they all got printed out without any sort of problems, and you even had a new line at the bottom. Now let's go ahead and discuss this part a little bit more. Let's go ahead and type in cout. I do believe that by just printing out the values of these of these sizes of these bytes of the sizes in terms of bytes will basically just be self-explanatory. Cout size of ARR, and go ahead, size of ARR 0. Okay, that should be it. Maybe I should do this as well. Okay. Let's run it. So it's 32 and 4. What is 32 and 4? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8. What is 8 times 4? 8 times 4 is 32. Why am I saying 8 times 4? Well, you have 4 here, and 4 is basically the size of the first element. What is the first element of the array? It's number 2. What is number 2? Number 2 is an integer. The size of an integer in terms of bytes is 4. So 4 bytes. So we basically said, okay, take the first element, give us the size in terms of bytes, which is 4, and then combine the bytes of all the elements, and then divide them by 4 to get the number of elements within the array. So let's go over that again. Integer has the size of 4 bytes in your RAM. So you have kilobytes, megabytes, gigabytes, etc. Well, integer is only 4 bytes in terms of size. Number 2 is an integer, which is the first element of the array. And we have stated, okay, go ahead and take the first element of the array, give us its size in terms of bytes. That would be 4. And then give us the size of all the elements combined in terms of bytes, which is 32. Okay, now divide it by 4 and give us the amount of elements. Give us the number of elements. Don't give us the size of the elements combined. Give us the number of elements within that the array contains, so that we would get the length of the array. Hopefully that is clear. So 4 is the size of a single element in terms of bytes. And once you combine all the sizes in terms of bytes and divide them by 4, you get the number of elements. Hopefully that explanation was actually useful. So this function that we have just created, the function print, is a regular, not a generic function which prints out an array of numbers, that is, integers. The problem is that the function only prints out an array of integers and nothing else. So if we had an array of, for example, real numbers, that is double, so if this was, for example, not int, but double, we would have problems. The function print will not print out these numbers. The solution to this problem is to write a function that has the same body, but also accepts an array of type double. So we could basically, we could go about doing that, and in fact we will. So let me just go ahead and type int here. There's a considerable amount of prep work before we get into what we want to get into in this particular tutorial in terms of generic programming, because you do need to do some preps. So if we basically just do this, void, we will create a function overload here. Print, and this will be double ARR. Okay. It's going to be int len again. So this will be an overloaded. These two functions are considered to be overloaded. Why? They have the same name, they have the same declaration, but they take different parameters. Oops, am I that stupid really? Okay, embarrassing moment there. Anyway, what we have done here is overloaded function, created an overloading function. So do you know what is the difference between these two functions? They have the same name, they have the same declaration, the same prototype, everything's the same except for the arguments that they take. So if you have two functions of the same name and they don't need to be void, they can also have a return type, but take different parameters, that means that you are overloading functions. So how would a program differentiate how would a machine differentiate if you call a function with print? They both have the same name. Well, it would differentiate in terms of the arguments passed. So if you passed an array of doubles, it will take this function into consideration. If you pass an array of integers, it will take this function into consideration. So let's go ahead and create the body for this function and see how that actually works in practice.